Hello! In this video, we are going to prove the following theorem. Let A, B, and C be n by n matrices. Then A plus B is equal to B plus A, and A plus B plus C is equal to A plus B plus C. So really, we're proving the commutative and associative laws for matrix addition. Now first, all a matrix is a rectangular array of numbers. So an m by n matrix would be a rectangular array of numbers with m rows and n columns. Now, we define the addition of two matrices as follows. Let A and B be any two m by n matrices. We define the m by n matrix A plus B as follows. So given any integer I between 1 and m, and any integer j between 1 and n, the ijth entry of matrix A plus B will be equal to the ijth entry of matrix A plus the ijth entry of matrix B. So all we're doing here is we're adding the corresponding entries of matrix A and matrix B to get matrix A plus B. So that is how we define the addition of two matrices. Now another thing, when two matrices are equal, this means that they have the same corresponding entries. More precisely, it means the following. Let A and B be m by n matrices. Then A is equal to B if and only if, given any integer I between 1 and m, and any integer j between 1 and n, we have that the ijth entry of matrix A is equal to the ijth entry of matrix B. Right? So it means that they have the same corresponding entries. Okay, so now looking at this theorem, we're trying to prove that these two matrices are equal, and we're trying to prove that these two matrices are equal. Now, let's look at the theorem to make sure it makes sense. And what I mean by that is, since A and B are m by n matrices, it follows by definition of matrix addition that A plus B is also an m by n matrix. Since B and A are m by n matrices, it follows that B plus A is an m by n matrix. So these guys are both m by n matrices, so they could be equal to each other. Right? In a similar way, we know A plus B is an m by n matrix. We know that C is an m by n matrix. Therefore, their sum, A plus B plus C, is also an m by n matrix. And on the right side of this equation, well, we know A is an m by n matrix. Since B and C are m by n matrices, their sum, B plus C, is an m by n matrix. Therefore, the sum, A plus B plus C, is an m by n matrix. So both the left-hand and right-hand side are m by n matrices, so they could be equal to each other. So, yeah, these two equalities make sense. But now, let's prove them. All right, so let's get into the proof. So let's first prove the commutative law. We're trying to prove that these two m by n matrices are equal. And to prove that, we're trying to prove, given an arbitrary I and j, we have that the ij entry of A plus B is equal to the ij entry of B plus A. So to prove that, since we're trying to prove a statement about all I and j, let's give ourselves arbitrary I and j. And from here, we proceed to show that the ij entry of A plus B is equal to the ij entry of B plus A. And to see how that happens, well, writing out the ij entry of A plus B, well, by definition of matrix addition, the ij entry of matrix A plus B is equal to the ij entry of matrix A plus the ij entry of matrix B. So we can write this as the ij entry of matrix A added to the ij entry of matrix B, like this. This comes from the definition of matrix addition. But remember, the entries of a matrix are numbers, right? Maybe they're real numbers or complex numbers, whichever you like. But we know that the commutative law holds when we're adding numbers. So we could flip these guys around and write the ij entry of matrix B plus the ij entry of matrix A. But then, by definition of matrix addition, again, this is precisely the ij entry of matrix B plus A. Right? We're just adding the corresponding entries of matrix B and A to get this. So, what does this show? This shows, given arbitrary I and j, we have that the ij entry of matrix A plus B is equal to the ij entry of matrix B plus A. But that's precisely what it means for matrix A plus B to be equal to matrix B plus A. So we can conclude that matrix A plus B is equal to matrix B plus A. So that proves this equality. Now we're going to prove this equality. Again, we're trying to prove that two m by n matrices are equal. And to show that, we want to show for all I and j, the ij entry of this matrix is equal to the ij entry of this matrix. So to prove that, let's give ourselves arbitrary I and j once again. From here, we proceed to show that the ij entry of this matrix is equal to the ij entry of this matrix. So let's write out the ij entry of this matrix. Well, by definition of matrix addition, the ij entry of this matrix is precisely equal to the ij entry of matrix A plus B plus the ij entry of matrix C. But then, right here, we apply the definition of matrix addition again. The ij entry of matrix A plus B is equal to the ij entry of matrix A plus the ij entry of matrix B. And now at this point, all we're doing here is adding numbers. And we know that the associative law holds when we're adding numbers, so we can move the parentheses around the ij entry of B and C. So we have this. But then, right here, we apply the definition of matrix addition again. Right? The ij entry of matrix B plus the ij entry of matrix C is equal to the ij entry of matrix B plus C. But then we apply the definition of matrix addition once again. Right? The ij entry of matrix A plus the ij entry of matrix B plus C is equal to the ij entry of this matrix. And so what have we shown here? We have shown, given arbitrary I and j, this equality shows that the ij entry of this matrix is equal to the ij entry of this matrix. So since I and j were arbitrary, we have proven for all I and j, the ij entry of this matrix is equal to the ij entry of this matrix. And that means that we have proven that the two matrices are equal. And so we have proven these two equalities. So this completes the proof. And so yeah, that's pretty much it for this video.